Only write down what you need to write down. Okay, these are your notes. Make it make sense to you. A dilation is a non-rigid motion. It makes things bigger or smaller. It stretches it. So it doesn't keep the same exact size of a figure. It has the same shape, but not the same size. And we talked about similarity yesterday. So if you don't want to take this as a note, that's okay. If it makes sense to you and you know that we talked about congruence a couple days ago, now we're talking about similarity. Two geometric figures are similar if we can map one to the other through a series of rigid transformations and a non-rigid transformation, a dilation. Have your note sheet from yesterday? So a similarity transformation is a composition of rigid motions and dilations. Combine some similar or some rigid motions and some dilations, and you've got a similar transformation, a similarity transformation. Everybody ready? Again, just write down what you need to write down so that you understand this. Okay, so we want to graph triangle FGH. Easy stuff. We've been graphing along a lot this chapter. And then we're going to take it and we're going to reflect it across the x-axis. Great review for our upcoming tests, right? And then we'll dilate it, the image that we received by reflecting. Test will be Monday. Okay? We're reviewing tomorrow. Okay? So let's start. F is 1 over 2 up. And G is 4 over 4 up. H is 2 over 0 up. Draw your triangle. First, they tell us to reflect that across the x-axis. And then they want us to dilate it. So Maddie, what do we do when we reflect across the x-axis? You go down. Good. So is H moving if we're reflecting across the x? No. So this is our H prime. H prime is staying at 2, 0. Okay? What's happening with F? It's going down. So Michael, where will F be? It was at 1, 2. Where will it be if we reflect it across the x-axis? 1, -2. Very good. So F prime is at 1, -2. Okay? T, where is G going to go? It was at 4, 4, and we're reflecting across the y-axis. Other way. We're going down. positive 4, negative 4. So G prime is at 4, negative 4. Okay? Rigid transformation, same size, same shape. Those two figures are congruent. Okay? Now, Ian, what are we going to do if we want to dilate H, F, and G by 1.5? Multiply them, exactly. So 2 times 1.5 is going to be what? 3. We double 1.5 and we get 3. So H double prime is 3. When we take 1.5 times 0, we're going to get 0. So we are 3 over 0 up. There's our H double prime. Okay? Braxton, if I take F times 1.5, what will I get from my new, F prime times 1.5, what will I get from my new coordinates? 1 times 1.5 is 1.5. And then negative, I'm taking 1.5 times each one, negative 3. So F double prime will be 1.5 over and 3 down. Okay? Andrew, what will G be? It was 4, negative 4. So if G prime is 4, negative 4, what's G double prime going to be? We're going to take 1.5. Try that again. We're going to take 1.5 times 4. Good. And then negative 6. Very good. So 6 over, 6 down. This is our G double prime. So non-rigid transformation, these are similar now to the other two. Our image is similar to our pre-image and our interim one. Okay? Everybody good on this one, or do you have any questions? Good? Because 1.5 is our scale factor, it's our K. That means that we take each part of the coordinate and multiply it by 1.5. It depends on the scale factor. If K is 1.5, you do. Sometimes it's 2, sometimes it's a fourth, sometimes it's a half. Yep, the problem will always tell you what K is. Or we'll give you 2 figures and ask you to find K. Okay? All right, next slide. Here we go. Yes. Yeah. So the thing to realize now is on your worksheet or on your notes sheet, the next 3 problems are for you to do. Very similar to what we just did. Okay? 1, 2, and 3 are those for you to do. That's part of your homework. Okay? Along with 4, 5, and 6. So you only have 6 problems tonight. Okay? 6, that's it for homework. Okay? And they're all on this sheet. So I want you to skip down to the next one that has a box around it. Okay? The one that has a box around it. Describe a similarity transformation that maps trapezoid PQRS to trapezoid WXYZ. Okay? So similarity transformation taking us from PQXY to WXYZ. Sorry? Yeah, absolutely. There's a place in the back. Okay. Okay. All right. So What do you think, guys? Blue 1 to green. Obviously a dilation. Is it an enlargement or a reduction? Blue to green, remember, blue to green. It's a reduction, okay? So we have a dilation, that's a reduction. Okay? And the orientation's different too, isn't it? Okay? It looks like a reflection. Is everybody okay with reflection and not rotation? Okay? Down for reflection. Across which axis? The y-axis. Very good. So we are reflecting across the y-axis, and then we're reducing. Okay? So that's what you will write. Reflection across y-axis and a reduction. But we have to say how much we're reducing. Okay? How big is PQ? How long is the distance between P and Q? Good. So the distance between P and Q is 3. Which segment represents or is similar to PQ in our other figure? Which segment corresponds to PQ in our other figure? There's nothing that's congruent. WX or XW. How long is WX or XW? Okay, so you told me this is a reduction. The way to remember how to do this is to always write your new length over your old length. So new over old. Our new length was 1. Our old length was 3. So what's our scale factor here? What's K? 1/3. Okay. So you can say reduction K equals 1/3. Or you can write it in the way that your worksheet does. You can say that x, y is being mapped to 1/3 x, 1/3 y. Either one's fine. Thumbs up if you're okay with this one. Anyone needs to see more? Okay. All right, next one. You can do all the coordinates and figure out where things are as well, but if you can visualize it, we've done enough of these to visualize it, you may be okay with just looking at it. Okay, so here's our last example. Okay, the last one in the boxes. Describe a similarity transformation that takes trapezoid WXYZ to trapezoid PQRS. WXYZ is the blue one again. That's our pre-image. QPRS is our green one. So what is taking us from the blue to the green? Riley? I'm sorry? A rotation potentially, okay? Could it be a rotation? It could. With a slide, right? Okay. Can you see that this is 90 degrees different, but it's got a slide going on? Because if we rotated it 90 degrees or 180 degrees, if we rotated it 90 degrees, it'd be here. If we're 180 degrees, it's here. And some sort of slide. So there's not one right answer to these. There's multiple right answers to these. Okay? What else do you see? It's enlarged. Okay, definitely enlarged. Blue to green, it's gotten much larger. Okay, does anybody see a reflection? Riley does. Over which axis? The x-axis. Okay, so this could also be a reflection across the x-axis. So rather than deal with a rotation of 180 degrees, Yeah, I think this is better to say that it's a reflection across the x-axis. Okay, so how big is our scale factor? What's our k? Between r and s is 4. And what's the equivalent, the similar side or segment in the other trapezoid? 2. YZ is 2. So we are, again, remind me, reducing or enlarging? Enlarging. So we want to take our new divided by our old. Our new one was 4. Our old one is 2. So what's our k? 2. 2 over 1. We've enlarged it by a scale factor of k equals 2. Or we can map it as xy is going to 2x, comma, 2y. Are we good? Thumbs up if you understand. Sideways if you're not sure. Okay? We're good? Okay? All right. Assignment is the rest of the worksheet. There are 3 problems like this as well.